Hi, in this video we will do some examples in which we have a sum which gives you the area of some region. Now we have to find what is that region and then use the shape of that region to find the value of that limit. Remember that the limit of sum of delta x f of xi as I goes from 1 to n goes to infinity gives you the area of the region under the graph. So we are supposed to find what is f, what is the interval AB under the graph of f on AB here. So when you look at this thing, you always remember that delta x is independent of I. So you look for a piece which is multiplied to another piece which has some i's in it. Okay, 2 over n seems a good candidate for delta x. And then, while delta x is equal to 2 over n, and while we know that delta x is b minus a over n, so this implies that b minus a is 2. Okay. On the other hand, we know that this is going to be f of xi. And xi is a plus I delta x. Yes. So in this case, basically, we were going to have a plus 2I over n. We have to find such a piece here. But what we notice is this is not 2in. This is 6in. What does that mean? That means that probably there's a number 3 multiplied there. So this is 3. F of xi is 3 times 2I over n plus 1. And you would say, well, where is that a? Well, if a is 0, we don't have any problem. So this will be 3 times 0 plus 2I over n plus 1. Yes. So in this case, we set it a equal to 0, then everything else worked nicely. So this was xi. So what we showed, this is 3xi plus 1. And we found that a is 0. Remember that b minus a was supposed to be 2. So from there, you know that b is 2. What we found is that the area, this limit is the area under the graph of f of x is equal to 3x plus 1 on the interval a is 0, b is 2. Okay, well, what is such a graph? So I have this guy and 3x plus 1, this will be 0 here. At 1, there will be somewhere there. That will be the graph. Yeah, something like that. But for 1 and 2 here. Now we are trying to find this region here. Yes. No, we have to find that. This is a nicely shaped region. We can find the area of that while using the this value is 1. So basically we have a thing like this. Here is 1. Here's when you plug in 2 there, this will be 7. So this is 7. Here is 2. Well, I'm using the right trapezoid area here, so that then the area is going to be equal to half of 7 plus 1 times 2, which is 8. Or what you could have done is that there is a big triangle here minus the small triangle there. And then this is 1, this is 7. Or how about this piece here? Well, set it equal to 0. This is negative 1 over 3. So this will be 2 plus 1 over 3, and here will be 1 over 3. So if you subtract that from there, that will give you the same number as we got there. Well, yeah, that is the number we were looking for. This is the area, and the area we can find just by knowing area of a triangle in this case. How about this one? Okay, again, so you try to make delta x and f of xi. Delta x, this is a good candidate, 6 over n, and we know that this is supposed to be b minus a over n. That means that b minus a is supposed to be equal to 6. On the other hand, f of xi is that xi is going to be a plus I at delta x. Here, I don't know what is a at this stage, but what I can see, this is I times 6 over n. And I have that piece here. So f of xi is root 9 minus 6 in minus 3 squared. Well, you say, well, where is a? Well, actually, it is here. I can rewrite this thing as negative 3 plus I times 6 over n, which will tell me, okay, if I set a to be negative 3, this guy is 9, squared. This guy is 9 minus xi squared. Well, we found the function. Function is f of x equal to 9 minus x squared. How about a and b? A is negative 3. Well, knowing that b minus a is 6, we will get b is equal to 3. So on interval negative 3, 3. Well, what kind of graph has this function? Well, this is actually an interesting function. This is f of x equal to root 9 minus x. Let me write it as y equals to 9 minus x squared. Then you find x squared, y squared is equal to 9 minus x squared. And this is y squared plus x squared equals to 9. Well, this is the graph of a circle radius 3 and centered at origin. Why do I have just positive part? Because we took the positive root. So this will be the sum is the area of semicircle of radius 3. Yeah, and we have a formula for that. We know that the area of the circle is pi r squared, but this is semicircle, so this will be half of that. And as a result, you see that this limit, without any computation, I can say that this is 9 pi over 2. So these examples are important. You have to be able to go backward when someone gives you limit of Rn or Ln. You have to be able to generate what is the interval, what is the function, and sometimes use other information to evaluate that limit.